Science comes first, right? So why did they ask a scientist to come and talk to you guys? Is anyone here doing a continuing education course in biochemistry or medicine? Need credit points? Did you come here today to learn science?
Yes.
Well, I hate to break it to you, but you don't have to, okay? And even though I'm talking science today, it's not the purpose, really. I learned a while ago, like when I first got this job, I thought that was my job, teach you guys science. But you don't have to be an expert in the science to sell the products, do you?
No.
But what do you have to have? You do have to have a belief that they are real, that they're actually doing something good for you. You have to have a belief in the quality. I would say it even boils down to the word passion. Do you think it's good if you're passionate about the products you're selling?
Yes.
If you don't believe that they really work or that the science is real, are you going to be passionate about it? Right. That's all you need, right? If you have passion, if you know, it's more than just a sort of a fake belief, but if you've seen maybe the scientists talk about it and you say, wow, that was convincing, I really believe it. And I even have a science friend that was sitting next to me. There's probably some scattered amongst the room, right? If you know one of the scientists in the room, ask them, is what this guy talking about fair income? Or is he just making it up? Is he just trying to trick us, right? Because by the time I'm done tonight, that's what I want, really. Have some confidence in the science of beauty. Is that good? All right, that's the deal. So today, I'm going to talk about the science of beauty. I'm going to talk about the fact that we're not just covering up ugliness or age, right? We're actually getting to the science of why we age, and we're getting to the science of skin and beauty, because that's the only way to really make a difference in the world, right? So it's not spackle, it's science, right? Does that make sense? All right, so let's get started, shall we? Today, I'm going to share with you 3 secrets to healthy aging. Now, here, I'm going to start by telling you about my friend Frank here. How old do you think he looks in this picture? Looks about 80, doesn't he? Yeah, would it surprise you to learn that when I first met Frank, he was actually 90 and he was riding a big motorcycle in Park City, Utah. Yeah, and he told me, he said, I've had an interesting life. I used to sell brushes and then I became a lawyer, and he just did so many things, and he was just, a very bright, very engaging kind of character. And then I lost track with him for about 10 years. So this is 11 years later. When I met him, he moved into my neighborhood. So that's me and my kids meeting with Frank. He's 101 in this picture. Yeah, a picture of health. He walks around. His wife has died many years before, but he's got several younger ladies, about 20 years younger than him, that are quite interested in him. So they're all in their 80s, right? So I love this guy. He actually died on his 104th birthday. And he told me that night, I saw him on his 104th birthday, yeah, I'm feeling a little tired today. I think I'll just lie down. And that was his last night. What a way to go, huh? I don't know if you remember the guy named Ross Algie. Is he here tonight? He once said to me, my goal is to die young, as late in life as possible. I think that's what Frank did, right? That's what we want to do. So that's when I talk about aging, it's not really about living to 100. It's really just about living healthy all the days of your life, right? Okay, so 3 secrets to healthy aging. Do you want to know what they are? All right. The first one is in the circle at the top there, nutrition. Whoops. Okay, nutrition science. Now, a lot of you probably wonder, well, wait a minute, that's not what I came to hear. Nutrition, what's that got to do with aging well? Most people actually don't immediately see a connection. So I'm going to help you to see a connection between nutrition. And what do I mean by nutrition? I'm really talking about micronutrient nutrition. What's micronutrient nutrition? Vitamins and minerals, right? Micro means like really small. So we're not talking about your rice or your meat or your, the fat, the protein, the carbohydrates. We're talking about the micronutrition, vitamins, minerals, stuff like that, right? So, to help you understand how it's related to aging, I'm going to show you this slide here. Do you know what this slide is about? Seems kind of random, doesn't it? The sign up there says triage. Who knows what that means? It's a French word. Yeah. It actually comes from one of Napoleon's surgeons, a very smart man, Baron Dominique Jean Lery. right? You probably never heard of him, but he actually invented the ambulance. Saved so many lives. He also invented this thing called triage. Tri means 3, right? Any nurses amongst us? What's triage? Can you help me? Yes, perfect. Prioritizing who to treat first. If your system, if your little hospital, whether it's at the battlefront or whether it's here in Chatswood, is overwhelmed suddenly by some kind of event where there are a lot of injuries, then a special nurse called the triage nurse comes out, and she has to prioritize. If someone is so badly injured that it would take every surgeon in the hospital, all night to fix him, then everyone else would die. So, maybe we need to leave that person. If you have an injury that we can easily fix and save your life, stop the bleeding, whatever, that's the middle, right? And then the others are the ones that just have a flesh wound. Like, what are you even here for, you baby? Just put a Band-Aid on it, right? So that's what happens in medicine. Did you know your body does the same thing? If your body is marginally deficient in any of the micronutrients, then your body has to make a decision about where to send that nutrient. And it will send it to the system of your body that is needed for you to survive today, right? And it will be at the expense of a system that maybe has a longer term kind of downstream effect. So I'll give you an example to think about. What about calcium? If you don't get enough calcium, what happens? Yep, okay, so your bones get less dense because you really need calcium for your bones, right? But you won't notice it straight away, right? I didn't have calcium last night, so my bones are weak, right? It takes a long time. You notice it as you age. Now, the calcium is going somewhere. The calcium, what little you get in your diet, because you're not getting quite enough, is going to be triaged to the systems of your body to keep you alive today. That would be the neuromuscular system, right? In order for you to think, for the neurons to fire, so that you get muscle contraction, you do need calcium and some of these other ions. That's how the body works. Okay, it's actually electrobiology, right? There's if you can have an ion gradient, then you can actually have this potential voltage, actually, right? We'll talk more about that later. It's very interesting. So, you didn't know that, right? Keep the system alive today. If your body didn't do triage, it would be kind of funny, if not tragic. Imagine if your body decides, maybe I'm going to just give you strong bones today. And you're walking across the road in Chatswood, and suddenly you get kind of a brain freeze, like, what am I doing here? And then your muscles freeze up, you can't move, and then you get run over by a bus. Do you see what I mean? To survive today, your body has to do triage. So I could talk for another 3 hours about all the other vitamins and minerals and how they impact you and where they need to go. But I think you get the picture, right? If you want to age well, don't ever find yourself marginally deficient in any nutrient. And I'm supposed to be talking science and not product. And, how did that picture get snuck in there? Oh, sorry about that. Hope there aren't any regulators in the room. All right, we're still talking science. The second secret to aging. Oh, does anyone know what that is? Did that? Yeah. Antioxidant science. Okay, free radical biology. Now, free radical biology we started to realize it in the 50s, but a scientist who made it famous was Dr. Lester Packer. And he was actually on our scientific advisory board for many years until he died last year. This is a really interesting area because free radical biology is about subatomic particles impacting your biological systems, right? Molecules with unpaired electrons that then suddenly need an electron, and so they attack the electron-dense parts of your body, your cells, which are the cell membranes and the DNA. When that happens, then there are long-term effects about how you age. So what's the answer? You need to provide antioxidants, right? It's pretty simple, but that's the second secret to aging. The third secret, let's talk a little bit more about those. Okay, I was going to quiz you about some common antioxidants, but now the answer is here. All right, so vitamin C, vitamin E, some of these antioxidants. Here's some interesting ones. Why do we have these minerals here? Micronutrient minerals. Selenium, copper, zinc, manganese. Why do they belong here in this kind of list of antioxidants? They actually have other functions in the body too. Zinc is really important to help bind proteins to keep their structure. It's in about 100 different enzymes. Here's the answer, because you probably don't know. Your body does create these antioxidant enzymes. Did you know that? So as your body is exposed to more oxidative stress, maybe you're exercising a lot more this week, or maybe you're flying in a plane and you're exposed to cosmic radiation. Scientific studies show that your body actually does adjust. It's amazing how the body sort of recognizes more free radical damage. Okay, I'm going to start creating these proteins. Do you know where that message comes from? It comes from the nucleus of the cell. Inside the nucleus, what is in there? Science students. Sorry? Yeah, the DNA is inside. The DNA. And the DNA is really all of the instructions for life. And when DNA gets a signal somehow from the outside of the cell or inside the cytoplasm of the cell, there's oxidative stress, there's free radicals here, a signal goes to the DNA, the right part of DNA, the right gene, then starts to make copies of itself, and then as a result, a protein is born, and that protein is born without teeth, okay? Maybe the protein is called glutathione peroxidase. It fights free radicals, but no teeth. Poor little thing. It can't do anything. It wants to kill a free radical, but it can't. So where does it get its teeth from? Its teeth come from your diet. The glutathione peroxidase needs some manganese and some copper. That's the active site. That's the tooth for the enzyme. Then it can fight a free radical. So if you're marginally deficient in any one of those minerals, what happens? Poor little Pac-Man with no teeth. And you can't fight free radicals. You can't adjust to the added stress of your environment. It's an amazing system. So what do you need to do? Make sure you get up antioxidants, right? They come from nature. We are particularly interested in some of these colorful ones called the carotenoids. Have you heard of those before?
Yeah.
Do you have a favorite carotenoid? You must have a favorite carotenoid. Beta carotene is one of everyone's favorite carotenoids, right? Eat lots of carrots. Did you know that one big carrot has 10,000 IU of beta carotene? 10,000 international units. That's plenty. Is it better to eat it raw or cooked? I hear raw. Actually, you'd be wrong. Cooked, because it breaks open the cell and the carotenoid becomes more available, right? So cooked tomato actually works a little better than raw tomato. That's why I like pizza so much, right? All right, so what do they look like? They're interesting chemical structure. Very unique, in fact. They are a first line of defense antioxidant. They're the colors found in nature, the red, the orange, the yellow, right? These are fantastic antioxidants. When you eat them, they actually get into the cell membrane of all of your cells. You'll see it even in your skin. If you have a lot of carotenoids in your diet, your skin will glow and be healthy. And you will be able to protect your cells from free radical damage. Wouldn't it be great if we could measure these carotenoids specifically in your skin to see if you had good antioxidant protection? Wouldn't that be good? Someone should invent that someday. Some of you who are new might not know it, but actually that did happen, right? A number of years ago, about 15 years ago, at the University of Utah, they have this famous group of physicists there that love to tinker with light and this thing called spectrophotometry. And another department at the University of Utah said, hey, did you know that these carotenoids, especially lutein and zeaxanthin, are really important in the macula of the eye? They protect it from blue light, the high energy radiation. They also help you to see. And if you have low levels of those carotenoids in the eye, you are more likely to get this age-related disease called age-related macular degeneration, one of the leading causes of blindness amongst the elderly. So this was a good project for the physicists. They discovered a thing called Raman spectroscopy. Actually, it was Kemvat Raman in 1930, I think, that discovered this, won a couple of Nobel Prizes. They just took advantage of this. The very low-powered blue laser light, they were able to measure it in the eye, right? And when they got sick of working with eyes, they thought, let's turn the laser power up a little bit. Let's turn it up to 11 and see what we can do with it. See if we can measure carotenoids in the skin. And they did. They published papers on it. And then they asked Nu Skin if we were interested. And we said, well, let me think. Yes, we are definitely interested, right? So we turned that, 4-foot argon laser that needed liquid nitrogen to cool it into this beautiful little device here. And now we can, I didn't mean to press a button. There we go. Now we can scan people. Now we can measure carotenoids. And here, this is a small experiment that we did with 7,429,432 people. Just a little experiment. And we got the average scans, right? And here's the bell curve that we saw, right? Now, the average person who eats less than 2 servings of fruits and vegetables appears somewhere around here, right? Are you guys average? No. I don't think you guys are average in any way, right? You're here on a Saturday. You could be out at the beach or something. You guys are amazing. And you certainly don't want to have an average scanner score. But the average Australian gets 2 or 3 servings of fruits and vegetables a day. And to be quite honest with you, it's probably chips and tomato sauce. Those are the 2 vegetables they get. Right? So we want to do better than that. If you score up here, you're probably getting 6 servings of fruits and vegetables. If you score around here, you're probably getting, 10 servings of fruits and vegetables. We actually designed our life pack to give you the same level of not just carotenoids, but the same level of carotenoids in the right proportion that you would get from a diet rich in fruits and vegetables, plus all those other antioxidants as well, okay? So who wants to be up here? Is anyone here up in the blue region? Yes. Hold up your hand. Good job, you guys. Anyone platinum here? Yes. These guys here? Awesome, yeah. What do you have to do to become platinum? Yeah? Life pack, eye formula. Do you have a good diet? Do you smoke? No. Good. Because smoking is one of the things that will really drag your score down. So if anyone wants to have a roadmap to their health, get a biophotonic scanner scan and see where you are now, and then just try to improve it a little bit, okay? I have some teenage children. I have 8 children. Is that not crazy? And I had several of them in high school who had terrible diets. Pizza, hamburgers, they weren't interested in food at all. One day, 2 of the girls came home and they were suddenly excited about eating fruits and vegetables. Can we have more vegetables for dinner tonight? I'm like, what is going on? You guys need to talk to me. There's something happening, right? This is like the drug talk or something. And they said, well, we were at the running store today and there was this little machine. It said PHARMANEX on it. You work for PHARMANEX, don't you, Dad? And they got scored and they were kind of in the low side, and so they wanted to see how high they could get. So that changed their lives. They actually, I'm not a vegetarian, but 3 out of the 5 girls are vegetarians now. This whole thing changed the course of their health path. I think if you can change the life of a teenager, you can change the world, right? Definitely. This is world life-changing technology. All right. Well, if you want to know more, you can find out more. So the next question is, what's the 3rd secret to healthy aging? We're going to focus in on this a little bit. We're talking about gene science now, right? Now, this is an interesting area because I'm going to give you some basics. Your DNA that you're born with, right? It's kind of some of your mum and some of your dad. So you're a recombinant of your mum and your dad. You've got this genetic profile, right? Every cell in your body, nearly, has 23 chromosomes, all of the DNA, all of the instructions for that cell and for your body, right? Does it change? Does the DNA code change as you age? It is fixed. It's like a book. It's like once that book is published, it's bound. That's you. That's your genetic background, right? Now, if your parents didn't age well, what does that mean for you? It kind of means, okay. The thought was that aging is inevitable and there's nothing you can do about it. And if you have inherited sort of not healthy aging genes, bad luck, you drew the short straw, right? That's kind of where it might lead you to go. But there's more to the story, right? There's more to the story. Do you remember when I said that if your body is suffering from free radical attack, that your body can adjust and react? What does it do? What does the body do? I told you. It sends a signal to the DNA. And the DNA is the same in everyone, but suddenly something has changed in the environment, so the DNA gets a message, and the message is you need to upregulate the production of endogenous antioxidant little Pac-Men, right? And those Pac-Men will fight the free radicals. So you see the system. It's not just about the book, but it's about the signal that's getting to the nucleus. So now it seems that the new paradigm is that you may be able to change gene expression. That's called gene expression, right? There are 25,000 genes in your DNA, at least. Those are the instructions that you need. And you can turn those instructions up or down, depending upon, how you want your future life to be, right? Your body is reacting to the environment, whether it's free radicals or normal stress or other things, right? So let's delve into that a little bit, right? Because let me tell you, before we delve into it, how we do innovation at Nu Skin. Do you want to know how it works? How do we decide what product to give you? How do we even decide to go into this area of genetics or nutrition or whatever it might be, right, for healthy aging? How do we do that? I'll give you some of the paradigms here. We have kind of a push-pull thing going on at Nu Skin at corporate. We have these guys called marketers, and we have these guys in R&D, our little R&D teams, right? 75 scientists. The marketers focus on a certain area. It's a little bit like what you focus on. What's hot right now? What are people really wanting? My customers keep asking me if we have this or that. Oh, I go to the store and I see that, this particular type of lipstick or this shade is just amazing right now, it's taking off. So marketers look at trends and they say, if this is a really hot trend, we really ought to have that product, right? And then where do they go? They go to R&D. And R&D, well, our job is to try to make it unique, right? So the marketers go, okay, there's this new shade of lipstick, you need to do that because it's really hot right now, but, you need to make it different. You need to make it somehow compelling. Maybe make it even redder, right? Okay, so there's an issue there. Do you understand that? Is that, we can't compete in every area just because it's hot. Some of you may be disappointed that we don't have some products that other companies have, but we are not a Me Too company, right? We need to look and see, is this a unique area? Is this a niche? Because that's what Nu Skin does, we innovate. We don't just copy or do what everyone else does because it's hot. Now, sometimes the marketer might get right on the money, but here's how the scientists think about it. We are like cute little spiders. We're not ugly spiders, we're cute spiders in a web. I tried to make this very unthreatening, not like the average nasty Australian spider. We're in a web. We all have our areas of expertise. Our 75 scientists have different areas, immunology or cell biology or sports nutrition or free radical biology or dietetics, whatever it might be, right? We get together, but we're all basically like spiders in a web waiting for an area that we love to sort of get a ripple, like some new discovery in that area. And when that happens, we pounce on it. And we go, wait, here's a new area. Something's happening in this area that's new. Let's see what we can do with this. Let's do some studies. And then if it turns out, we can offer it to marketing and say, this is new, right? We'll learn about some new stuff tonight. Most of the stuff that you learn about at Nu Skin is kind of new and different because we're innovators. That does command a slightly higher price, right? Some of our products are more expensive than our competitors. The reason is because of the innovation and the science behind them. Okay, so we did see some movement in this area of biology and gene expression. So I already talked about some of the new developments there, the old paradigm, but then suddenly this new understanding of how the gene adapts, how the DNA adapts to changes in the environment. So this is an area that we then started to focus on. This expression of age-related genes that can be influenced back to a more youthful state. That was what we were focused on. Can we do that? So here's the backstory a little bit, okay? We saw a publication by these two scientists. Have you seen these guys before? Some of you who are new probably haven't seen them, right? Richard Weinrich is a gerontologist, a guy who studies the aging process, right? There are a lot of them now. It's really interesting, actually. When it comes to trends, about 30 years ago, I think there were 5 labs in the world that had gerontologists that were studying aging. Now there's over 300. Why do you think that is? Because where the people are aging, and actually the people with all the money, that was the baby boomers, are getting older, and suddenly they're interested in aging, and so they put more money into that research. Now, the thing is, in a way, they're wasting their money. That's just my perspective. The reason is because most gerontologists really are just studying the biology of aging. They are making observations, and they can tell you stuff. Stuff like, as you age, your hair may go gray. And that's not all. We can tell you why it's going gray. See, there are these stem cells in the follicle that get old, and that's part of the coloring process and blah, blah, blah. And you're like, okay, but can you cure it? Well, no, aging is inevitable, right? Or as you get older, you'll start to forget things, right? I forgot what I was going to say next. But you see, they were just sort of looking at what's going on as you age, but they weren't saying you could change that paradigm, right? This, though, because of his background, which I'll describe a little bit later, this scientist, Dr. Weinrich, did believe, based on evidence, that you could actually slow the aging process. That's what makes him very unique, right? And some of the work that he did, very unique. The scientist over here is actually a geneticist, and he looked at the work that Weinrich was doing, and he said, I wonder if we could measure aging at the genetic level, right? As the aging process goes on, what are the gene expression changes that are happening, right? Not just if you have increased oxidative stress, but what about all the other changes that happen as you age? Can you measure the gene expression? Well, you can. You do it with this little guy here called the gene chip. Have you seen one before? Yes. We're going to have a fish and chips night tonight without the fish, okay? This is the gene chip. I was talking with John earlier tonight, and he said, how does that gene chip work? We keep hearing about it. How does it work? Do you want to know how it works a little bit? Yeah. It's really kind of cool. When I was in college, if anyone's done any biology in college, you can actually learn to extract DNA from a bunch of cells. You get a bunch of cells and you have them in this flask and you use certain things and you do purification steps and you end up with this gooey, stringy stuff. It's the DNA that you extract from the cell. It's pretty cool. Well, it turns out you can also extract the RNA. So let's go back to that example of the cell is under oxidative stress, right? And there's one gene in there that codes for glutathione peroxidase, that little Pac-Man guy. Well, if you were able to extract that cell, what's going on is the DNA is making lots of copies of that gene for that protein, that antioxidant protein. That's called RNA. Makes lots of copies, right? In the cellular world, you've got photocopiers there. And if you want to produce the plans for a certain building or a certain recipe, basically the cell just makes lots of copies of that recipe. And if you make enough copies of the recipe, then eventually the translation process will make that into a protein. So the more copies of that recipe that you see, that means that that gene is expressing itself, right? Do you get it? Still with me? All right. So now we get a bunch of cells, and we say, okay, I wonder which genes are expressing themselves. There are 25,000, let's see. So you extract the DNA, the RNA. You have to be super careful because every finger touch will actually has RNases on it that will break it down. So these are very delicate. You put on your gloves and you extract the RNA from that cell. And then we have this chip, this gene chip. It looks like this. And there's a silicon chip on there, and we put on there about 40,000 probes. The DNA bit that the RNA would come from. And when that RNA finds the DNA that it comes from, it just sticks. It's kind of like a lock and key. So there are 45,000 probes on there, and if you have the right RNA, it'll stick to that DNA, and the more of it, the more lighted up it will get. So you see the background there? Some of these genes are lighting up. It means that that's active. Where it's dark, it's not. Does that help? That's the gene chip. All right, who wants one of these? Yes. Answer me a question. What's the first secret to healthy aging? Nutrition. Who said? I heard nutrition over here. All right, there you go. A gene chip. All right. What's the second secret to healthy aging? Antioxidant. I heard antioxidant with a lovely French accent in the front. All right. What's one of the third secrets to secret aging? Okay, the lady in the back with blonde hair on that side. Okay, just kidding. I'm going to pass it back. My sound guy said if I get off the stage once, he's going to turn the sound off, but thank you for keeping it on. All right, so we learned a couple of things from the experiments that were done by Weinrich. This is very cool. They taught us a couple of things. They taught us that, yes, all right, that as you age, there are changes in gene expression, right? And that is key, because if there are changes in gene expression as you age, then now we have something to measure it by. And if you can measure something, maybe you can change it, maybe you can influence it. So that's the first experiment that we did. We tried to limit it a little bit. We said, okay, what's one thing that happens as you age? You start to lose energy. We know biologically why. there's an organelle in each cell. There's hundreds of them, and it's called the mitochondria. The job of the mitochondria is like little nuclear power plants, combine oxygen plus fuel to get energy, right? It's kind of a cool system. How many genes does it take to build and maintain the mitochondria? It takes about 1,000. We found that 52 of those genes change dramatically over our lifespan, over our age. So as the mitochondria become less efficient, it's due to changes in these 52 genes. If you count the rows, there's 52 rows here. And this is the young gene expression. Basically, you know, all these genes that are expressed in green are low expression. But as you age, they switch. They start to express themselves higher. And vice versa. These ones were high, now they're low. You get it? Okay, so now we know that. Let's look for ingredients that can maybe change it back. We would feed it to old individuals for 3 months and then measure the RNA and see if we are getting a young kind of expression. You get that? Right? This is kind of new, groundbreaking kind of science. We did that experiment. Now, we're really good at partnering with our experts. So we have a gerontologist, you know, he has the concept that aging can be slowed. We have the geneticist who taught us how to measure aging at the genetic level. But Nu Skin, we have experts in the kinds of ingredients that might influence aging. We also have expertise in exactly how much and where to get it from, right? Not drugs, but natural compounds. Things like the carotenoids or the flavonoids or other things. So we screened about 50 different ingredients. Some of them really stood out. You'll see that one of these is not like the others. Which one? Yeah, ingredient number 4. Anyone know what that is? Cordyceps. Who said that? Me. One gene chip for you. Yeah, cordyceps is, it's a really interesting kind of a mushroom fungus that was discovered in the high plateaus of Nepal. They have yaks there. The yaks are eating the grass, and the fungus grows up through the grass. It looks like dead grass. And those yaks were renowned for being very frisky, if you know what I mean, eh? And the other thing is that the horses that lived in those areas had amazing stamina. So the people that lived on those plains were able to sell their horses at a much higher price because they just seemed stronger, could run further. Isn't it interesting that now as we apply modern science to this, we find that that ingredient changes gene expression ultimately to produce healthy, younger mitochondria, the energy-producing organelle of the cell. Isn't that amazing? It comes full circle from thousands of years of China tradition to modern science. So, of course, we would produce products from this kind of science, and that's what we do, right? You're familiar with some of these products. Not too much of a product session tonight, we're talking more science, but that's the origin of some of these ingredients that we have in R squared, right? All right, now, it was time to move on to the next phase of our experiment and give you a little bit more background depth. Do you remember I said that Weindrich believed that you could slow the aging process? He believed that because he saw science that suggested that that is possible, and he repeated some of that science. What he discovered was that in 1935, and this is well known, a scientist by the name of McKay out of New York did some experiments with some rats. He made sure that he basically cut their calories by 1/3. The amount that they were eating every day, he cut it. Right? They're eating much less. Very strict dietary regimen, not very easy to do. But they were in a cage, they had no choice. But he didn't break rule number 1. What's rule number 1 of healthy aging? Nutrition. Who's that? The lady in red back there. Oh, I'm so sorry. Did I hit your head? Throwing chips into the audience. Next up, you're throwing fish into the audience. All right. So he didn't break rule number 1. He made sure they had adequate micronutrient nutrition. He just lowered the calories. What happened to these rats? They lived longer and they were healthier. It was really quite a remarkable, not just a little bit longer, about 50% longer. So this was a very strict nutritional regimen. Scientists really then started to be abuzz, like what's going on? Is it slowing metabolism when you eat less? That means that you use up less calories and therefore it's kind of like a fire, it burns longer and not brighter. They just didn't know. So they repeated it with flies, it worked. With worms, it worked, right? The C. elegans worms. With yeast, it also worked. They then did it with mice, totally worked, right? So it's working with all these different species that are just miles apart. And Weindrich believed this, and he said, well, no one's done it on humans, and we can't do that, but let's do it on the closest relative, rhesus monkeys, right? So his experiments have been going on for, more than 20 years. And what did he find? Well, the experiments aren't over yet, but here's the red line. This is the normal sort of death rate, and here's the red line when this strict caloric restriction regimen is imposed. It's quite remarkable. And it's not just about how long, once again, but we've got to be like Frank. It's about being healthy all the days of our lives, and that's what the science shows. All right, so this brought up a really interesting paradigm. Now, I didn't go to business school, but I'm thinking maybe we could do something with this. Let's say we start this direct selling company and we give people a proposition. I'll tell you what, we've learned that strict dietary regimens can help your life. So you give us I'll take your food and you pay us for taking your food off you. What do you reckon? Do you think it would work?
No.
You guys are just too savvy in the business department. Okay, so we've got to think about that. Well, what about measuring that pattern of gene expression? And much like we did with the mitochondria, are there ingredients found in nature that could give us that same pattern of gene expression? So now we're not just looking at mitochondrial gene expression, we're looking at all 25,000 genes, and we're looking what's the pattern of gene expression associated with this very strict nutritional regimen that most of us would not enjoy? Do you get what I mean? So here's what it looks like. This is a typical aging. You can see this is a lot more complex, a lot more genes involved here, right? Typical aging profile, these are the genes that change as you age, right? Well, you have to correct me now because that's not exactly right. Not exactly changing as you age, but this is the model of healthy aging that we talked about, right? These are those guys that are on the strict dietary regimen. They're not old yet, but the gene expression pattern has already changed. This is the path to healthy aging. Do you get what I mean? This is kind of a new dimension to this gene expression work, right? So here's typical aging, here's healthy aging. What kind of a profile do you want? Do you want this one or this one?
The top one.
Healthy.
Right, well you can get that one. Just impose on yourself an extremely strict dietary regimen, right? And give me your money. All right, not gonna work, but what if we screen for ingredients that help us to have that same profile, right? Let's do that again, and that's what we did. This was a huge undertaking, a lot of gene chips. Do you know how much those gene chips cost that I just threw out into the audience?
No.
They're $500 each.
Oh, wow.
And then for the chemicals and the procedures that you need to process them, it's another $500. So each gene chip experiment is $1,000. And when you do these experiments, you need to do them not in just one alone, you've got to do them at least in triplicate. We did them in octuplicate, right? So you've got to get the normal mice, you've got to get the mice that are having this ingredient or that ingredient. How many ingredients? 50 ingredients. So 8 times 50 now, right? But we didn't just stop there. We have to look at the tissue in the brain, the heart, the muscle, the liver, right? So we're looking at all the different tissues. We're doing these experiments in octuplicate. It's costing $1,000 every time we do it, right? It's going to add up pretty fast, right? Millions of dollars. I'm going to just cut a long story short. Millions of dollars and 6 years it took us. We finally found our favorite ingredients. Then what did we do? We had to combine those ingredients and then feed them again to confirm this, right? Do you want to see what the result looks like after we found the right ingredients and did that experiment?
Yes.
You sure?
Yes.
All right, that's what it looked like.
Oh my God.
Have you seen that before?
No.
Isn't that amazing? We found it unbelievable, right? So actually it was so unbelievable we thought maybe we made a mistake. Because let me go over that. You remember how many experiments we did? And each experiment actually results in 40,000 data points, right? There's 40,000 data points on this chip. And we've got hundreds of experiments. So would you like to do the statistical analysis? Right? This is not something that you can do in a calculator or even with an Excel spreadsheet. There's a new science called bioinformatics. This is if you go to universities now, some students are learning this. It's using computer algorithms to analyze big data. So we thought maybe they made a mistake because this is pretty amazing. But we don't want to be really embarrassed like those cold fusion experiments that they did in Utah a couple of decades ago, right? So we decided to get a second opinion. We sent all of the raw data to an expert in Europe, a big data expert, who has a slightly different way of presenting and looking at this data. And the way that he does it is called principal component analysis. You can write that down and check it with your statistician friends if you like. And so what he's doing is representing in three-dimensional space, like the y-axis, the x-axis, and now the z-axis, what gene expression looks like in the young group of data. And then what it looks like in the old, the normal aging, the typical aging, right? Remember, this represents like that line on the bottom. And then what does it look like in that strict nutritional regimen? And it looked different again. It looked more like this up here in the green. Okay? So now, according to his bioinformatics statistical sort of calculations, what did the age-lock blend look like? What should it look like? Trying to get it to look like this, right? Here's where it was. So if I draw spheres around those, that's what it looks like. It's not completely overlapping, but it's pretty amazing, don't you think? So second opinion, check. All right. What do you think?
Amazing.
Amazing, right? Okay, and so that then, of course, gives rise to more product development. Yes. All right, so the next thing is to do lots of experiments to see if, okay, we've got the gene expression change, does it actually make a change in your body? We did that. So we've done experiments on the brain. It's very promising. All the data is done. We've just got to publish it, okay? And I'm kicking my research team saying, we've got to publish this, get it out the door so our distributors can see it. We've done other work as well. I'm just going to share this one with you. This was kind of one of the, you could do an experiment with humans, right? But it would take maybe 40 years. Take age-lock, see me in 40 years, just take it every day of your life, and then we'll check off and see if you're aging better, right? Should we have done that? Well, maybe your grandchildren might have reaped the benefits of this amazing product. But there are other things that you can do. You can look at models, and skin is actually a very good model. If you look at my skin, you can kind of tell how old I am, right? I hate to say it. Good thing we don't have the high-definition screen up here, right? But you could probably narrow it down within a decade most of the time. So the skin is a very good model of aging. So we went to our favorite dermatologist who does clinical studies and asked her to test this, and she was not very hopeful. She said, look, if you put topicals on the skin, especially some strong drug-like topicals, you will see differences. But she said, I've never really seen differences if you have an internally taken ingredient, right? But we did the experiment anyway. She said, what the heck? Nu Skin's got lots of money. Do the experiment. Spare no expense. So we did. So we looked at, for example, on the top 3 lines, the dermatologist assessment. And then the bottom 2 lines is the self-assessment, looking at radiance and texture, overall appearance, etc. And this is the improvement that we saw after 3 months on the product, right? It's not over in the blue zone yet, but it's still amazing and it's statistically significant, and our dermatologist was really amazed by these results, right? We also have a very objective way of measuring elasticity. So do this with me. You can tell kind of how elastic your skin is by squeezing the skin on the top of your hand. Have you ever done that before? Yeah. Squeeze it, and then let it go after a couple of seconds, and how fast does it go back? Right? Now, if you're super young, it's just going to go boing, and you don't even see a line. If you're a little older, you'll see that line kind of hangs around a little bit too long. You go, dang. All right. So we want to increase elasticity because that's part of the youth, right? Now remember, this was not a product designed to enhance elasticity in the skin. It was a product that we designed after gene expression experiments to show that it's going to slow the aging process. So look at that number on the bottom. After 3 months on the product, it went from 32 all the way up to 41.4. Pretty amazing, right?
Who's our subject?
Sorry?
Who's our subject? Are they human? Subject.
Yes.
In this experiment.
Humans. Yes, humans. Yeah, we didn't do monkey in this one. Yeah, this is humans, right? Yeah, no problem. Okay, so while we're talking about skin, I think some of our friends are going to come up on the stage and do some demonstrations, because, about this time of night, you start to get a little bit bleary-eyed because of all the science. So we need to give some little show and tell, right? I don't have any more chips left to throw into the audience. So Tracy's going to come up here with one of her human subjects. And Amanda, thanks for volunteering, Amanda. And we have a videographer, good. Last night we had a man and I said that he looked like he was a stalker, and so I think he's not coming back tonight, so. All right, so Tracy, what are you going to do here?
So I'm going to do a galvanic spa demonstration, and then after that we'll do a Lumi spa demonstration.
And while she does that, you can just look there occasionally, put one eye on her and then one eye on me and all your ears on me, right? So we'll talk a little bit more about this. So here's another example of innovation, where several years ago, one of our skin scientists, happy little spider in the web, felt a disturbance in the web. A fly had landed right about here. And the fly that landed there was to do with the galvanic spa. The background science of this is there was this guy around the 1750s or something born named Luigi Galvani. Right? This is a really interesting time in science. There was some weird science going on at this time, right? We were learning a lot about anatomy and how the human body works, and he discovered something called bioelectromagnetics. Any idea what that is? He was doing experiments, and at the time he was trying to work out how nerves and things work. I don't know what it was, but he had frog legs on the table that had just recently been bisected, and one of his careless assistants accidentally touched the frog leg with a scalpel that had sort of been charged with a little bit of static electricity. And what happened when he touched that frog leg in the right place? The frog leg kicked, right? Suddenly they're like, whoa, wait, that's interesting. Should we follow up on that? Do that experiment again? What did you just do? Right? And that's what he did. He started to discover this concept of how electricity impacts the nervous system. Now, we talked a little bit earlier about bioenergetics, right? We talked about how you have these, that a cell that has a semi-permeable membrane, it can build up ions on one side, and there you have sort of a resting potential. And the body actually does then turn this into an active potential by, for example, sending pulses of electricity down a nerve fiber to cause muscle contraction. This is what they were discovering at that time. Very interesting. We learned that the cells also react to these small voltages of electricity. It helps to move fluid around the cell, all sorts of things. It's a sort of an energizing thing for the cell, right? And from that time then, well, you know, what's really interesting in the backstory is, have you ever heard of Mary Shelley? She wrote a series of books about Frankenstein, the modern Prometheus, yes? Where did she get her inspiration for this? Her family actually knew Galvani's family, right? One of Galvani's sort of contemporaries started to do weird experiments in public places with recently decapitated corpses and things. You know, like charging with electricity, and they would suddenly sit up, or their hand would clench, or the eye would open, right? So it was kind of macabre kind of science. Thankfully, it evolved a lot from there. Frankenstein, kind of cool stories, you know, but it really, you know, it was born with this concept that there's a relationship between electricity and animation or life, right? And it's true. Now, we're not generating huge volts of electricity. We're not sort of sending towers into the sky and waiting for lightning. This is about, you know, in the millivolt region. Even a single cell can generate a potential of about 50 millivolts across the membrane there. So safe, small levels. And as you saw in the picture earlier, anesthetists have been using the galvanic electricity, this positive charge, to help with skin and to improve skin condition and vitality for quite a long time. So what was the fly landing in the web? Well, these devices that they use in the esthetician's offices cost about $60,000. They require trained technicians, and everyone's skin is a little bit different in how it conducts electricity, so you have to calibrate the machine just right for everyone. What the fly in the web was a guy had discovered, just using a circuit board, how to make a device that is tiny and is able to self-calibrate. When you first put this galvanic spar on the skin, then it actually calibrates to the exact level that it needs to be for Amanda's skin. right? What do you feel? Have you had the first
Yes.
pass through? What did you feel so far, Amanda?
I feel fresh.
Did you feel stinging, biting, burning flesh?
Extremely fresh.
Good, okay.
Extremely
No to all of those
fresh.
things.
There you go.
You can barely
Right.
feel it. Every now and then you feel a little prick. I don't know if you've done this before, but it's very mild. Really, the only things that are feeling it are the cells, right? Okay, is there a particular sort of way that you do this, Tracy?
Yes. So I've just put the Age-Lock gel on as the second step, and that's going to increase cellular energy, which is what you were talking about before. But when you watch me, I'm going to be moving in an upward motion around the forehead and then up over the cheekbone, and always in a lifting motion with a bit more pressure going up and then lighter pressure going down, because you have to keep the device on the skin.
Right.
It's really important. Yep.
Because it's creating sort of a link between your skin and the device and Amanda's face. All right. And what's really interesting also is that there's a couple of phases here, right? So have you ever played with magnets when you were a kid? It's very much like electricity. Have you ever got the south pole and tried to touch another south pole of a magnet? What happens? It repels, right? So some of the actives that we use in the first phase are actually charged, right? Many biomolecules are charged. And so it's actually a nice way of using the galvanic spa to push it into the skin. Then when you change the polarity, so what happens when you switch one around, north-south, then it sticks, right? So then that second phase can actually pull those cleansing molecules out of the skin and take that with it. So there's a really nice cleansing effect along with that sort of enlivening effect of the skin. So, what Tracy is also doing here tonight is called the half-face demo. A little backstory on this device. Not every innovation that we come up with is immediately appreciated. Some of it takes a little bit of science to explain, and if it's kind of too hard for you to explain it, imagine someone comes to you with this device and you've never seen it before, and they say, this is a galvanic spa. And if you use it on your skin, you'll feel a difference. It's based on the work of Galvani, and it's really kind of cool, and well, maybe you should read Young Frankenstein. All right, it's not all that easy, right? But there are techniques. But what actually happened was when we invented this, when we sort of first made this, some sold, but it wasn't crazy. And in fact, after a few years, I remember sitting in the executive boardroom with a number of the leaders of the company saying, well, we've got 5,000 in inventory right now globally, and they're just not selling that well. It's a real shame that this wasn't a hit, because it was a pretty cool fly on the web for our innovation. So I guess we're going to have to ask permission from our CFO to dispose of these units, because they're just not selling. Then something happened, another fly on the web on the marketing side. Someone in Europe discovered, what if I did a half-face demo just like Tracy is doing now? Do it on half the face, so that when someone looks in the mirror, they go, the half that she did is awesome, but she didn't do the other half. I can totally tell the difference, right? That alone triggered like this amazing revolution in the area of the galvanic spa. Suddenly, our demand had increased just 100-fold. We were selling 50,000 a month globally in no time at all. It's incredible what a difference that marketing program made. And you know who found that, who discovered that? It was distributors. Distributors that discovered how to do that and then enacted on that. So that really does demonstrate actually the unique partnership that we have. We can have marketers in the company looking at sort of what are the demands right now, what are the trends. We can have scientists who discover a new area of research and do the experiments and the science and package it up. But unless we have really creative marketing and sales in your teams, we won't actually see it gain traction. It's a really common thing. So we're really excited that this one gained traction. All right, we all done?
We're done here.
All right. Well, it's probably hard for you to see which side looks better, but I bet when Amanda looks in the mirror in the next hour or two, she'll see a difference.
How does it feel?
I feel my skin is smooth and fresh, really fresh and really clean.
Excellent.
Great, thanks a lot. Thank you.
Right.
All right. So what we're seeing here, we talked about the science of beauty. And we have these active ingredients. These are usually the focus of personal care ingredients. These active ingredients that we use at Nu Skin are based on science, and they're based on the science of beauty. But what we're doing is we are multiplying the effect of these active ingredients by using some of these unique technologies. And the Galvanic Spa is one that has stood the test of time amongst you. People can really see a difference, right? We're going to move on now to another area. And that is, does someone want to take a picture of that? Let me just go back there. There you go. That's awesome. Take a picture. It'll last longer. All right. And so now, after the half-vest demo, we're going to talk about another, same spider, same web, looking at a different area, a different fly landed in the web. This is one that a few years ago, one of our scientists, Dale Kern, discovered an area of movement in one of the areas of interest. He said, that's interesting. Wow. They're doing these new studies on cells. And this is the paradigm. The physical body needs exercise. It needs to move in order to stay healthy, right? All sorts of things happen, right? Your heart gets stronger when you do physical exercise. I don't know if you've ever heard of the lymph system, have you? As an immunologist, this is of extreme interest to me. You know all about the blood vessels, right? You know about the veins. And you know about the arteries, right? The arteries are taking the freshly oxygenated blood from the heart, taking it and the lungs, to the rest of the body. And then when that oxygen is depleted, the blood goes from red to kind of more of a purple color, and it comes back to the heart through the veins, right? So arteries, veins. Did you know there's a whole other circulatory system in the body called the lymph system? So it's the same. But that doesn't have a heart that's pumping it around the body. As the body moves, it kind of compresses and decompresses the lymph system, and so that sort of leftover blood gets back to the heart. And that's carrying a lot of the immune cells, and so your immunity and things like that are very important. This is why massage and movement are very important, right? Well, it turns out, this is the research that we found, is that cells seem to crave the same thing. Cells are not healthy unless there is movement. So right down to the cellular level, you need movement. And we're particularly interested in whether or not that movement is important in the skin of the face. So that's some of the research that Dale Kern did. He said, well, this is interesting research. Let's do some experiments here. He was able to secure money from Nu Skin, right, to be able to do some of this research. Now, we're doing a lot of this research all the time, and we don't have a 100% history of success, but we need to do this very pioneering research in order to get somewhere. So, as we did it, we had to look, as Dale looked at it, what kind of vibration are we looking at? If you squish the cells, does that work? Like put some pressure on the cells? Or does it have to be a vibration? And if it is a vibration, how much movement? What's the amplitude of that movement, right? How far? And then what's the frequency of that movement? Is it fast that far or slow that far, right? So there's a lot of variables to play with. He had done 4 clinical studies before we presented it to marketing, and found exactly from the experiments in tissue culture at first and then with real human skin, the impact that it can make on the cells. So this is the device that we're using now called the Lumi Spa, right?
Yes.
And so we're using a particular gel.
Yes, so we were using the normal combination cleanser with the device. So we've just demonstrated half face on that. And I just love how it almost glides itself over the skin. So you literally hold it onto the skin rather than press onto the skin. And how did it feel?
I feel relaxed, and I feel very clean. Like the Lumi Spa is really gentle on my skin, and at the same time, I feel relaxed. Yeah.
It's amazing how many things this one product will actually do. Yeah.
Yes. So you'll see there, we tried several different models. One of the first devices had prongs that moved up and down, and one was just pressure on the skin. One that worked best is the one that you see now, which has counter-rotating heads, right? There's one in the middle that goes the opposite direction of the outside, right? So basically it has a dual effect. These are some of Dale's experiments, but I won't go through them. There is a dual effect here. Oh, you can get a bit of an idea here of what happens when you do move the skin at the surface. There's so much underneath the surface of the skin, some of these cells, and you see the movement of, sort of like that lymphatic system that you have in the cytoskeleton of these cells, that are then producing proteins that help with the aging process. So can you see that we can apply topicals to the skin, but isn't it interesting that as you move the skin, that the skin does some things for itself that help in the healthy aging process? This is the science of youth that's really powered by two, not just active ingredients, but also helping the skin to work. Isn't that pretty cool?
Yeah.
All right, so there is a deep clean effect there, but then there's this skin renewal, sort of youthful looking skin component of this LumiSpa. We've done 7 clinical studies now. I'll just remind you that we have 5 of the different treatment cleansers, right? So this is a personalization thing. This is something that marketers have told us. Personalization is very important in the skincare area. My skin is not exactly the same as my neighbor's skin. Mine's drier, or mine's oilier, or mine's more sensitive, right? So between the 5 different types of treatment cleansers and the 3 changeable heads, you're going to find something that's perfect for your skin, that's really going to make a difference. Finally, this is where we differ from, selling Tupperware or something, where you buy it once and then you're good for life, right? It's actually very important, the medium that you use, right? The formulation that you use that's between your skin and the head has to have just the right viscosity. There's this whole science of rheology. By viscosity, I mean, the difference between honey and milk. Honey has a very thick viscosity, right? A high viscosity. Milk is very thin. If it's too thin, there's going to be too much grip, right? That's here, right? Too thin, too much grip. So it's excessive drag and it's going to irritate the skin. If it's too thick, then there's too much slip. Not enough drag, it's not moving the skin just right. So, right, this is like Mama Bear's porridge. It has to be just right so that the treatment head grips the skin surface and does exactly what it needs to do. So then you're locked in to actually buying one of the 5 treatment gels, right? Does that make sense? Great business opportunity for you based on good science. Okay, what's going on over here? Oh, we are changing the head of the device.
Yes, we have changed the head of the device to LumiSpa Accent, and combined with the Idealize Eye Cream, what this is going to do is actually help with puffiness, a little bit of puffiness and dark circles, hydrate the eye area, and also deal with little fine lines and wrinkles. And I love it because this little head is very gentle.
Can you do a close-up of the head or
We
not?
can't. We don't have the connection.
Okay, no worries.
Okay. But it is very gentle, and I'll just
All right, you go ahead, and I'll talk a little bit more about what's going on here. So,
yeah.
look at this head here. This is the old head, and it was quite large. And this is another thing that I love about our relationship with our sales team, you guys, is that we get a lot of brilliant suggestions from you. So our customers, after using this for quite a while, said, I'm really interested in this part of the skin, but it's really delicate, and you've told us to avoid this part around the eye, right? Because we had done experiments everywhere else. But I really want to do this part. And so we thought, well, maybe there's a way of doing it. This is too big. So we designed, and we tried lots of different designs, but we ultimately ended up with this design, which is slightly longer fingers of this really soft kind of silicone that gives us exactly the same kind of motion, the same amplitude, the same frequency, but now you're able to use it in sort of this orbital area, right? We don't do kind of right inside that part near the nose, but just from here going out and from here. And this is then going to help with the puffiness and things like that that Tracy was describing.
So we're all done.
Excellent. All right.
Good. Nice. Thank you.
Thank you so much. Oh, it's fun, wasn't it? All right. Well, I'm nearly done here, except just to maybe summarize. We have this innovation process. It's combined with kind of sort of demand. But remember, this is the science of beauty. What we've been able to do is combine beauty from the inside and healthy aging with beauty on the outside, but real science of beauty, right? That means not just spackle, Not just covering up the signs of aging on the skin or in the body, but actually finding out why this happens and helping the body to help itself, right? We learned about the 3 secrets to healthy aging, right? Nutrition and antioxidants and gene expression. We talked about how that gene expression was done, remembering that you don't have to be scientists, you just have to have a passion, right? I hope that you can join me in having more passion about the science of beauty and these wonderful products that we've innovated for you so that you can share them with your friends and be a force for good. Thanks very much, everyone.